Right, Enlargements Chapter 14, the higher course. 14.1 Enlargements and Scale Factor has been adequately dealt with using the foundation videos, so click on the links above my head somewhere. I'm not going to touch any page 182, 183, sorry 192, 93, 94, 95 and jump straight into section 14.2 Centre Enlargement. That was done under the foundation course. I'll do one grade C question, then jumped into grade B, and then very quickly we'll be getting into grade A. Not this video obviously, but okay, here we go. This is question 2 on page 197. It says, in this diagram A has been enlarged to give B, so that's the baby, that's the enlargement B of baby A. Find the scale factor and the centre of enlargement. Well, centre of enlargement first. Let's use this lovely facility. Again, if I take this point here and drag it through the corresponding point from which it was enlarged, I'm going to get centre 0, 0. But hey, we can't get the centre of enlargement just based upon one point. Let's try this one and that one. Drag it all the way through, just see where it goes. Looking good so far. That's 2 out of 2. I think I'll take this one and that one together, and that should also go straight through 0, 0, and it does beautifully. So the scale factor is going to be centre enlargement is going to be 0, 0, and the scale factor, well, let's just count some squares, shall we? If we look at the top part of this trapezium, it's 1 unit across. Here we go, 1, 2, 3 units across. So that looks like an enlargement of scale factor 3. Well, let's just test it one more way. If you look at the base of the trapezium, we go 1, 2, 3 units across, and if it's a scale factor enlargement, scale factor 3, then it should be 9 units across the bottom. Let's just count. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, it is. So scale factor 3, centre of enlargement 0, 0. It's very beautiful. Just get a nice straight ruler, sharp pencil in an exam, join some corresponding vertices, draw the lines all the way back, and you need at least 2 or maybe 3 is better of lines or construction lines drawn back, see where they cross, and it's very easy to see where the centre of enlargement is, and that's a starter question at grade C. Right, here's a question I began. Let me just put the grid back on here. Grid, display on screen. There you go. Makes sense now, doesn't it? Right, this is question 3. It says draw a pair of axes from 0 to 16. Well, I've done that, haven't I? I've gone 0 to 16 all round. It says go 0 to 16 from the x values, so 0 to 16 there, and y values 0 to 8. Well, I went up to 16 anyway for the fun of it. So I've labelled and plotted the rectangle E, the coordinates 6, 2, 6, 4. So 6, 2, 6, 4, 10, 2, 10, 4. That's these coordinates here. It's been done previously just to save a bit of time. It says draw the image of rectangle E, that's rectangle E, after an enlargement to scale factor 1.5, in other words 1.5 times, with centre 0, 0. Alright, so this time we're going to start from a known centre of enlargement. Let's just put construction lines, or little light rays I like to call them, through each vertex, and we'll see where we go. And again, it could be a bit complicated doing this one. Anyway, I'm going to enlarge its scale factor 1.5. Now, the great fun about enlarging from 0, 0 is you can count squares to get the positions of the new vertices. So look, if I work in, say, blue now, if you look at the point 6, 2, if I'm going to multiply the scale factor by scale factor 1.5, I've got to multiply the 6 by 1.5 and the 2 by 1.5. Now 1.5 6s will be 9 across, and 1.5 times 2 for the y-axis will be 3. So I should end up with 9, 3. Let's just check it again. 6 times 1.5 is 9, and 2 times 1.5 is going to be 3. So 1, 2, 3. Leave that there for now. Let's just do it with the point 10, 2. 1.5 times 10 is 15. 1.5 times 2 is 3. So I've got 15 and 3. And look, it's exactly on the construction line. Please note I didn't do construction line to join that vertex to the point 0, 0 and drag it through. It looks far too messy. But let's just do the maths on it. Here I've got the point 10, 4. If I multiply 10 by 1.5, it's 15. If I multiply 4 by 1.5, it's 6. So I've got 15, 6, and there it is, exactly on the line. Right, I can now use the rest of my lines just to finish off the shape. Look, So my next point would be there. Now look at it carefully. That to that, that to that, that to that. It's absolutely beautiful, isn't it? And that to that. And just to see if the vertex really does work, let's go back to red, 0, 0, join the corresponding vertices and draw a line straight through, and look, it works beautifully, doesn't it? Look at that, all the way through. Each vertex has its corresponding line. Each vertex has its corresponding vertex after the enlargement, and the construction lines go through perfectly. And this is now rectangle F. So this blue one is F. Alright, slightly bigger. Scale factor 1.5. What are the coordinates of the vertices of F? Well, I won't write them down, I'll just speak them out. We go 9, 3 for that one, 9, 6 for that one. That's going to be 15, 6 and 15, 3 for that one. We'll just label one, shall we? So 15, 3, and that came from which vertex? 10, 2. You see? So this demonstrates it quite nicely, doesn't it? So if I go 10 times 1.5, I get 15. If I do 2 times 1.5, I get 3. Okay, so it works mathematically, and if you enlarge it correctly, it will look right, it will be right. All the corresponding vertices will sit on the same construction line as we pass through, and that's a really lovely question. Bit of a mess, you don't have to do all this, but that's just me teaching it. Alright, so next question. So how does this go? Right, question 4. We've upgraded to B now, so I'll be a little bit careful how I do this. It says copy each shape onto squared paper. Okay, I've done it. Enlarge A, that's this one here, by a scale factor of 1/2. Okay, so we have fractional enlargements. This is being rated as grade B. I thought it was a C myself. Let's use red, it's lovely. Alright. Pass through each vertex, like so, and that one across there. And it says scale factor of 1/2. What I can do is measure each distance from the centre enlargement to each vertex and halve it. So I can use that as a technique. Stick to glue, I think. So 1, 2, 3, 4, 5, 6 squares. Half of 6 is 3 squares. 1, 2, 3. That's that one done. Again, work mathematically with this one. It goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Well, half of that is going to be 5. So 1, 2, 3, 4, 5. And it goes 1, 2, 3, 4 up. Well, half of 4 is going to be 2. So I'm going to go 5 along. 1, 2, 3, 4, 5 and 2 up. And I'm right there. Okay, so that's that one. That's that one. Now we do this one. 2 across. And 1, 2, 3, 4, 5, 6, 7, 8 up. Half the 2 is 1. And half of the 8 is 4. 1 along, 4 up. And look, it's exactly on the construction line, exactly in the right place. Now we simply join the vertices as shown, like that, that to that, and that to that. I think that looks absolutely beautiful. Okay, a very striking example of an enlargement by a fractional amount, by scale factor 1/2 in this case. Now a quarter is going to be a bit of a pain because it's rather small, but I have to have a go, aren't I? I might do it just mathematically because it's really, really titchy. Let's have a look. Now look, I've got to enlarge it by a scale factor of 1/4, and this is the centre right there. So I'm going to call that centre of enlargements, just in case you don't have that in your brain. That's centre of enlargement. I hope I spelled it correctly. Can't remember if you drop an E there after enlargement. I don't think you do actually. Put an N there. All right. Okay, so scale factor of 1/4. So distance from this centre of enlargement to that first vertex. 1, 2, 3, 4. Well, if I'm going to enlarge it by a scale factor of 1/4, I'm going to be quarter of a distance away. So I think that vertex there will just be right there. Now let's just study this. Let's get this bottom vertex. 1, 2, 3, 4. So to shrink it quarter the size, the bottom of this V, so to speak, is going to be right here. Alright, so that part is there, and that part is there. So 4 units tall, should we say, from that vertex becomes 1 unit tall when we look at the enlargements by scale factor 1/4. Now what about across here? 1, 2, 3, 4. Well, 1/4 of 4 is going to be 1 again, so I think we're going to go here, I think. Let's just look carefully. That doesn't get joined. That's going to be there. And this one goes 1, 2, 3, 4 to the left. So essentially 1 to the left. And these are my 4 vertices, which I will now try and join with a pretty red line. Let's hope I can manage not to drop this thing. So that goes up there, that goes there, that goes there, and that goes there. And that's okay. I didn't draw any construction lines there. I'm sure you can see that if I start to put a couple of lines through here and through there, it's going to be really messy. Well, since I've drawn it as it is, I'm going to leave it like that for you to study it for 4 seconds. Now I'll put my construction lines just to see that it was okay. And I'm going to go for blue. So I'm going to go through this edge here, and hopefully, okay, that's not too bad. And this one, that's not too bad. And of course, if I go straight through the centre, I grab both these vertices and they correspond to these 2 points there. Bit of a mess, that's why I didn't want to do it, but there you go. Hopefully you won't get one as tight as that in the exam. Certainly A is beautiful, very easy to show the construction lines. Here for this one, it's so small, it really gets in the way of the answer you're trying to portray. So that's that. And I think I want to stop at this point and maybe do question 5. Yeah, I'll come to question 5 later and do it as a separate vid. I think it could be a bit more involved. So I'm going to stop there, call that a starter video, and maybe continue 14.2 part 2 in a moment. So thanks for watching. Work hard.